Hello and welcome to this tutorial on writing chemical formulae for more tricky compounds that you might find in GCSE chemistry. So let's start with a quick overview of the basics of chemical formulae. I'm going to look at the chemical formulae of the compound water. Review, capital H is the element hydrogen and capital O is oxygen. Now, when we look at water as a molecule, we have two atoms of hydrogen and we have one atom of oxygen, and they are covalently bonded together into H2O. So the little 2 that is in that chemical formula there means that there are two atoms of hydrogen, and there's an invisible little 1 after the oxygen for one atom of oxygen. So make sure that you're really clear on what those little numbers mean in chemical formulae. Now moving on swiftly to a more tricky ionic example of a formula. Let's look at magnesium hydroxide. Now, magnesium hydroxide as a compound is made of the atoms the particles that you can see on the screen. We have one magnesium, and then we have two hydroxides. And a hydroxide consists of an oxygen and a hydrogen covalently bonded together. So we treat that as if it is one particle because of that covalent bond. And when these come together, we form a chemical compound, magnesium hydroxide. Now in total, there's one magnesium, there's two oxygens, and there's two hydrogens in that compound. But how do we show this as a chemical formulae? Well, there's a couple of ways you could do it. The first way would be, let's say we've got one magnesium, we've got two oxygens, and we've got two hydrogens. And that accurately represents how many of each there are, but it's not the right way to write that formula. And the reason for this is because the oxygen and the hydrogen are actually treated as if they are one unit. So you've got one hydroxide there and one hydroxide there. So if we don't write the formula like this, how do we write the formula? So we still have a magnesium, but because the oxygen and the hydrogen in the form of hydroxide come as a pair, we put OH in brackets to show that that's a little unit of its own. And because there are two of them, we put a little 2 outside of those brackets to represent those two hydroxides. So let's have a look at a slightly different example, potassium sulfate. Potassium sulfate is made of all of the atoms that you can see on the screen. Now there are two potassiums and there is one sulfate ion here, which is one sulfur and 4 oxygens covalently bonded together. And when this compound comes together, all of these come in to form a complex. Now that doesn't actually accurately represent what it looks like, but what we're interested in is how we write the formula of that compound. Now, we're going to start with the metal, which is potassium, so capital K. Now there are two of them, so we're going to do K2. Then we're going to do sulfur, and there's one sulfur. And then there are 4 oxygens in that compound. So the final formula that we end up with is K2SO4. All right, so here's an even more tricky example, aluminium nitrate. So aluminium nitrate is going to be formed of all of the particles that you can see on the screen. Now, what we have is aluminium, which is an ion, and we have 3 of these nitrate ions. Now, a nitrate ion, if you can remember, is written as NO3-, 1 nitrogen and 3 oxygens, covalently bonded together into what we call a group ion. Now, if we put the aluminium nitrate together, how are we going to write the formula for this compound? So we're going to have, I'm just going to rotate that slightly. We're going to have 1, 2, 3, let's rotate that around. 3 nitrates and 1 aluminium. So to show that ratio in the chemical formula, we're going to have Al, and there's an invisible 1 after the Al. And because the nitrate has come as a little package, I'm going to put it in brackets, and there are 3 of them, so there's a 3 outside. So don't get confused between this 3 and this 3. Have a look at the picture. 1 nitrogen, 3 oxygens in each nitrate here, so that's NO3. Then there are 3 of those nitrates around the aluminium. And what is also probably quite useful to do is to count up how much of each atom that we have. So just looking at the picture, there's 1 aluminium, There are 3 nitrogens in that compound, but there are 9 oxygens in total when you count them. And the way that you can also work that out from the formula is there's a little invisible 1 after the aluminium. Everything inside of the bracket is multiplied by this 3 outside, so there's a 1 here. So 1 times 3 gives you the 3 nitrogens, and then 3 times 3 gives you the 9 oxygens. And the last and most tricky type of chemical formula that you will come across is one for water of crystallization. So water of crystallization happens when an ionic salt crystal forms, like the one in the picture on the right-hand side. And as those ions crystallize and line up, molecules of water get trapped inside of the crystal. And you can see that because there are some gaps in between the particles, the ions of the crystal, and the water gets trapped in between. You can see this in this bottom left-hand side.
So let's take a look at the formula for anhydrous, or it's sometimes called dry copper sulfate. And that just means there's no water involved in this compound. So we have 1 atom of copper, and we have a sulfate, which is 1 sulfur and 4 oxygens, and they come together to form a compound. And the chemical formula for this compound would be CuSO4. So there's an invisible 1 here and an invisible 1 here, but because chemists are incredibly lazy, we don't include the little ones. So you end up with just CuSO4 because there are 4 oxygens. So let's move on to a more complicated form of copper sulfate, which is hydrated copper sulfate. And hydrated or wet copper sulfate has water bonded to it into the compound. We include 5 water molecules, and you can see them over here, 1, 2, 3, 4, 5. So we still have a copper, we still have our sulfate SO4, and we're going to bring in those 5 water molecules to hydrate that compound. Now this again isn't exactly what it will look like, but what we're interested in is how many of each type of atom are there in total. Now if we're going to write the formula of hydrated copper sulfate, we have to represent everything that is in that complex. So copper sulfate, as we saw before, is CuSO4. Now I said there were 5 waters, and we can still see them here in that complex. And the way that we show that there are 5 waters is we use a dot, and that means with, and then there are 5 times H2O. Now, chemists are incredibly lazy, so we actually just write 5H2O. And we remember that that means 5 times H2O. Now what we need to do next is look at how many of each type of atom there are in this compound. So to work out that, we're just going to count them. We'll use the picture. So we have 1 times Cu, we have 1 times S for sulfur. Now how many oxygens in total do we have? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 oxygens in total. And let's count the hydrogens as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 hydrogens in that compound. You can also just use this chemical formula to work out how many of each. Remembering that there is a little 1 here and here tells you that there's 1 copper, 1 sulfur. And then for oxygen, we need to count how many oxygens there are in the CuSO4 and how many oxygens there are in 5 times H2O molecules. So there's 4 oxygens in the CuSO4 plus 5 in the 5 times H2O, because each H2O has 1 oxygen atom. There are 5 of them, so 5 times 1 is 5. Hydrogen, all of the hydrogen is coming from the water. There are 5 H2O molecules, which means it's 5 times 2, which takes you to that total of 10.
Okay, so here in the top right-hand corner, I've looked up the ARs, the mass numbers of those atoms from the periodic table. And for copper it's 63.5, sulfur is 32, oxygen is 16 and hydrogen is 1. So to work out the relative formula mass of this entire complicated compound, there is 1 copper, so there's 1 times 63.5. There is 1 sulfur. There's 9 oxygens in total. And there is 10 hydrogens. So I'm going to do the sum for each of them, and then I'm going to add them together. So I add up 63.5 plus 32, 9 times 16 is 144, 10 times 1 is 10, and I get a total of 249.5. So that is the MR of that CuSO4.5H2O compound.
So let's just review some of the key terminology that we use when we talk about hydrated complexes. 2 words that are really important are anhydrous and hydrated. An anhydrous compound is sometimes called a dry compound. There is no water, there's no H2O. And for example, CuSO4, which is actually a white powder, white crystalline substance when it is at room temperature. Compare that to a hydrated compound, sometimes called a wet. It has H2O, and we can tell that from the formula because we have this .5 H2O in the formula here. And when copper sulfate is hydrated, it has .5 H2O. It is a blue color. So we're going to do a couple more examples of working out the relative formula mass of a hydrated salt. So this is nickel sulfate, NiSO4.6H2O. Let's work out its relative formula mass. If you are an A-level student, I am using a GCSE periodic table. Your periodic table will have more decimal points than this. So for example, looking at the periodic table, I can find that so in that complex, there's 1 nickel, there is 1 sulfur, there are 4 oxygens in that nickel sulfate, and then we need to include the 6H2O as well. So there's 6 waters, each water has 2 hydrogens, so there's going to be 12 hydrogens in total, and there's 6 waters, each one has 1 oxygen, so it's going to be 6 times oxygen. So it's quite useful if we just add them together to get a total. So overall, we're going to have not 4 oxygens, but we're going to have 10 if we add that 6. And I'll just rub it out from the other side as well. And then we can do our relative formula mass using the ARs from the periodic table. So I'm looking, and nickel is 59, so it's going to be 1 times 59 added to 1 times sulfur, which is 32. 10 times oxygen is 16 from the periodic table, and hydrogen weighs 1, so it's 12 times 1. Now I'm just going to do that sum and add it up. And the total that we get there for the relative formula mass of that compound is 263. Last example we're going to look at is hydrated beryllium nitrate, which is a very big compound indeed. So what do we have? Let's just decipher this chemical formula. Now, if there are brackets, I always start with the bracket and I work out from there. So I'm actually going to start with NO3 times 2, because of that little 2 outside that bracket means everything inside of the bracket is multiplied by 2. So if I have 2 NO3s, then in total I'm going to have 2 nitrogens, but I'm going to have 6 oxygens because 3 times 2 is 6. I have 1 beryllium because there's an invisible little 1 after that Be, and I've got 4 H2Os, so 4 times 2 is 8 hydrogens, and then I've got another 4 oxygens to add in there, which gives me a total of 10 oxygens. So having a look at the periodic table, nitrogen has a mass number of 14, so that would be 2 times 14. Oxygen is, sorry, I went 2 times 14. Oxygen is 16 from the periodic table. Beryllium is 9, and hydrogen is 1. So I'm just going to quickly add those up and get to our total. And when I add all those up together, I get the MR of that compound to be 205. So hopefully that has given you a good overview of different types of formula and how to analyze them and calculate the relative formula mass, or the RFM, of these types of compounds.